how would you find the antiderivative of the dx divided by square root of 6 plus x minus x squared? Notice that you can use two ways to solve it. The first way would be to use the factored form of this. This is factorable, which is great. You can factor it as 6 plus x minus x squared as 3 minus x multiplied by 2 plus x. If you don't know how to do that, just take negative x and then x first, place them in parentheses, and then think about which two numbers you would need here to yield you the sum of 1 as a coefficient of x and then the product as positive 6, right? You know that 3 times 2 is positive 6, and the sum 3 plus 2, the sum of 3x and then negative 2x is exactly positive x, right? So that's what you need to look for when to find. So now you will set this, if it's factorable, right? If this form is factorable under the square root, the trinomial is factorable, you're going to put it as any of these two factors squared. So let's put the 2 plus x and then square that and then multiply it by the u squared. So that's the type of the substitution that you would need. So whenever this is factorable, you can use any one of these two factors, square it, and multiply it by the square of the next variable that you're gonna substitute it for. So now you're gonna solve for x in terms of u. So notice that immediately 2 plus x can be let go, 2 plus x factor can be let go, so that 3 minus x is equal to only one factor of 2 plus x multiplied by the u squared, right? Simply divide both sides by 2 plus x, you will get that. So now 3 minus x, we're trying to isolate x so that we can solve in terms of u. And why do we do that? Because we need to find the dx after that, right? Because we want to transform this integral in terms of the second variable u, right? To make it easier to solve. So 3 minus x is equal to 2u squared plus xu squared. So as you can see, you can subtract xu squared on both sides, right? And you will have what? And then subtract 3 on both sides. So you will have x as, let's see, negative u squared minus 1 is equal to 2u squared minus 3. So now x will be in terms of u, and notice that these two are negative, so we can multiply both sides by negative 1, and it will give us this. It will give us 3 minus 2u squared over 1 plus u squared, right? Multiply both sides by negative 1, you get this for the right side, and then divide by the resulting left part, which is 1 plus u squared, right? Because it was multiplied by negative 1, you get this, right? So x is in terms of u now. Perfect. So we need that. Now we need to find the dx. The dx is going to be found by using the quotient rule, of course, right? So first the derivative of the top, so negative 4u multiplied by the untouched bottom, 1 plus u squared, minus the untouched, well, I would say the differentiated bottom now, and then the untouched top, right? So 3 minus 2u squared, and then divide this thing by the square of the bottom. All right, you get this. So this actually simplifies to negative 10u, if you do the algebra correctly, negative 10u over 1 plus u squared squared. And then we need to not forget the du in there, right? Because we're differentiating both sides, right? So that's the dx part. So now we're ready to actually, and there's actually one more thing before we're ready to finally put everything in terms of the new variable. Notice that the square root of this trinomial is going to be the square root of this, right? So the square root of 6 plus x minus x squared is going to be the square root of this, which is 2 plus x times u, right? 2 plus x, 2 plus x times u. But what was x in terms of u? Because we need to have everything in terms of u. right? So 2 plus x, x was this, right? So 2 plus 3 minus 2u squared over 1 plus u squared, right? So 2 plus x times u, and u is just u, right? So let's simplify that. We need the LCD 1 plus u squared, and then multiply it by u, right? And let's leave the u outside for now, but let's just simplify the inner part. So we get, as a result, we can simplify this to yield us 2 plus 2u squared, right? The LCD is 1 plus u squared, plus 3 minus 2u squared over 1 plus u squared, and this thing times u. So this is equal to 5, right? 5 over 1 plus u squared times u. Okay, so now we have the quantity of this, right, in terms of u, the expression for the square root of the trinomial. So now we're ready to actually, and let's separate this part because this is for substitutions. So now we can actually set up the antiderivative in terms of u, the variable u, right? So dx is this part, right? Let's put the negative 10 outside because that's a constant. Let's put a u and then 1 plus u squared, right? Du will place at the end, right? So now the next part is 1 over the trinomial, the square root of the trinomial, which was this. The trinomial was this, but we need to divide by this, right? Divide by this means we can flip this fraction. So the 5u will go on the bottom, right? And on the top we will have 1 plus u squared. 1 plus u squared over 5u, and now we can put the du. Perfect. Now notice why I held the u. I didn't distribute the u, because I can see that the u here can be cancelled out. And so is the 1 squared, the 1 factor on the bottom of the 1 plus u squared, right? So as a result, we'll have a much simpler integral. And also negative 10 over 5 is negative 2, right? So negative 2 integral of 1 over 1 plus u squared. Life is great, right? Because this is just arctangent, right? So this is equal to negative 2 arctangent of u plus a constant. Now putting everything in terms of x now, 6 plus x minus x squared, the square root of that, remember that square root of 6 plus x minus x squared was equal to the square root of this, right? Which was 2 plus x times u. U would be equal to the square root of this, and also we can factor this. Remember that 3 minus x, so this part was factored as 3 minus x times 2 plus x over the 2 plus x. 2 plus x. What is going to happen? Notice that square root of 2 plus x divided by 2 plus x without the square root means that there will be a 2 plus x square root of the 2 plus x in the denominator, right? So u is equal to the square root of 3 minus x over 2 plus x, right? So this fraction is under the square root. So that expresses the u in terms of x. Excellent, right? So that's going to be your antiderivative. Negative 2 arctangent of the square root of the fraction 3 minus x over 2 plus x, closed, plus a constant. So now this looks rather difficult. There's one more way that you can use to solve this. And I'm going to explain how the results will vary and how to understand that the results do not mean that either one is wrong. But let's first try the second method. The second method is to actually prepare this square root in such a way that it looks like a form that you can use for an arcsine antiderivative, right? And how to do that? Notice that we can actually complete the square. We can say that the given antiderivative can be expressed, the bottom of it precisely, can be expressed as 6 minus x squared minus x. Right? And then what you're gonna do next, you're gonna complete the square of this part. Right? So you're gonna have square root of 6 minus x squared minus x, and then the half of this coefficient squared, right, which is going to be plus 4 and minus 4. Plus 4 and then minus 1/4 dx, right, which is equal to what? Which is equal to simplified as 6 minus, now we can remember that we can actually group these three together, right, these three together, and then make this a plus sign, right, because if we take it outside the 1/4, the negative would make sure that two negatives become a plus, right? So this is what we're gonna do. So if you group this like that, you will make x squared minus x plus 1/4 as a perfect square factor, right, which is gonna be x minus 1/2 squared, right, plus 1/4. Right, so then let's keep simplifying. You will get what? You will get, for the constant, 24 over 4 plus 1 over 4 is 25 over 4 under the square root, minus x minus, and actually let's do one more thing. Let's make this a one fraction. So the LCD is 2, so we're going to get 2x minus 1 over 2, right? So 2x minus 1 over 2 squared. Now notice that this looks interestingly close to what we want, because we have a 4 here because it's squared 2, and then we have a 4 there. So we can actually factor out the 25 over 4. You might say, but there's no 25. But there's a way to make sure that the 25 is still going to be applied here. The following is the way that you can do this. You can have, so 25 over 4, we're going to take it out. So 25 over 4, we're going to take it out. So we're going to have 1 minus. So how do you make sure that the 25 over 4 applies here, but yet it wasn't there before? Well, if you multiply this 25 over 4 by the reciprocal 4 over 25, you will get 1 exactly, and that's what we want, right? So reciprocal, right, 2x minus 1 over 2 squared. Right, so now what are we going to have? We can, obviously 25 over 4, both of them are perfect squares, right, because you will get 5 over 2 outside that as a result, right? So 5 over 2 in the denominator will be 2 over 5 in the top, right? So 2 over 5. So we're going to have what? Square root of 1 minus. So now notice that you need to, it's almost ready to look like the form that you can use for the arcsine antiderivative, but you need to get rid of this troublesome 4 over 25. Notice that 4 over 25 can be expressed as 2 squared divided by 5 squared, right? So 2x minus 1 over 2 squared, right? So then notice that there's a 2 squared on the bottom and there's a 2 squared on the top. So you can actually cancel those guys out and just apply 5 squared there. But 5 squared, there's already squared accounting for the 5, right? So you can just replace this 2 with a 5, and this thing is completely gone as a result, right? So 2 over 5 integral dx over square root of 1 minus 2x minus 1 over 5 squared, right? And that's all there is to it, right? Again, notice that the 2 squared was cancelled out with this 2 squared, right? Because this 2 was also squared. And then 5 squared can be, so 25 in other words, can be put here, but there's already a square there, so we just need a 5 in there because the 5 will be squared. So that's how we got this. So now as a result, this is now ready for the for another substitution that then you're going to use for the arcsine antiderivative, right? So setting this as, let's say, u is equal to 2x minus 1 over 5, the du is going to be 2,5 dx. So 2,5 dx means that you're going to have a 5,2 as a constant. 5,2 will cancel out with the 2,5, give you 1, to give you 1. Right? So as a result, we will have a 2,5 multiplied by 5,2, right? Of the du of the square root of 1 minus u squared. And perfect. And now you're going to get the arc sine. Right? This thing will give you 1 as was just discussed. So as a result, you will get arc sine of u plus a constant, which gives you arc sine of 2x minus 1, right? That was the u value here. 2x minus 1 over 5. Put this 5 better. Plus a constant. You might ask me, why is the antiderivative different from the first one? Well, different doesn't mean wrong. Okay, first of all, you can differentiate both of these, and you will get this if you do correct algebra in both cases. Differentiate both of these results and you will get this original result. This is a little bit messy, but it's doable. If you do it right, you will get this derivative. But when I say derivative, you have to understand, if you want a primitive example, for example, if you got, let's say, the first function being equal to x squared plus 2, and then the second function being equal to x squared, notice that both of their derivatives would be equal. Would be precisely 2x. Right, so that's exactly the case here. So what I'm getting at is that the difference of these two antiderivatives that we got, right, the difference of these two functions, if you think parallel here, you will see that the difference will be simply 2. If you subtract the second function from the first, treat this as antiderivatives of these two derivatives. So if you subtract this second function from the first, you will get a constant value difference, not a variable. So basically what I'm getting at is that the difference of these two antiderivatives will be a constant value. And you can also check values starting from using the domain of this function, starting from -2 and 3, right? You know the domain of this is going to be from -2 to 3, and you can check -2 and 3 as well. You can include these, and you will see that the results, if you input each of these x values that you choose into each of these antiderivatives, you will see that the difference between the results will be the same. It will be the same constant value, such that in this case it was the difference of 2. Right? So that's how you should understand that antiderivatives may seem different when you use different techniques of solving and finding them, but it doesn't mean that they're wrong. Thanks so much for watching. Hope this was helpful. See you in the next video.